Our blue planet is a very peaceful version of what it used to be before. Here is a little brief history lesson on what is happening under Earth's crust and how Earth was made. It all started off with the Big Bang, approximately 13.7 billion years ago. The universe is triple of what Earth's age is. Earth's age is about 4.5 billion years old. In the early years of our solar system, there were plenty of asteroids and rocks floating around, constantly being pulled together by gravity, creating magma or a heated rock. After all these collisions, an early Earth had formed. All of these asteroids had combined together to become a molten planet. All of these impacts would result in a very, very hot, hell-like planet. After millions of years of constant collisions, the Earth had settled into 4 primary layers. The inner core, which is primarily iron and nickel, which is solid. It is held together by gravity. The outer core, which is made primarily of iron and nickel in its liquid state. After that, we have the mantle, also known as the asthenosphere, which is primarily made of molten rock. And last but not least, we have the crust, also known as the lithosphere. It is the part that we live on today. It is primarily made of granite and basalt. There are 2 types of tectonic plates. There are ocean tectonic plates and there are continental tectonic plates. Continental are more buoyant, they're made of granite, and they're older, while ocean plates are made of basalt, they're younger, and they're less buoyant. Both of these types of tectonic plates glide over the mantle. As you can see here, there are 7 major tectonic plates: the North American, the South American, the Antarctic, the Pacific, the African, the Eurasian, and Australian plates. Because the magma in the mantle is constantly moving, there is this thing called a Continental Drift. As you can see here, the original Pangea slowly spread into our modern day Earth. The reason for this continental drift lies beneath the Earth's crust. The core is very, very hot because of all the pressure and gravity pulling down on one centered piece. This heats up the mantle, which causes a convection current to occur. The hotter magma rises to the top and lets the colder magma, which is releasing heat at the top of the Earth's crust, to sink down back under and get heated again by the outer core. This creates a current to occur which little by little moves the tectonic plates. The Earth's inner core rotates the opposite direction of the outer core, which creates a magnetic field around the Earth, which protects it from extreme solar radiation. The Earth is considered a living planet because the convection currents help move the Earth's plates. There are 3 different plate boundaries: a divergent boundary, which is when the plates move the opposite direction, and the magma in between them fills in the crack, and this is known as seafloor spreading. An example of a divergent boundary would be the Iceland Rift. The next plate boundary is called a convergent boundary. This is when 2 plates are pushed together. An example of this is the subduction of an oceanic plate under a continental plate. And last but not least, the transform boundary. This occurs when 2 tectonic plates slide past each other. This causes severe earthquakes. An example of this is the San Andreas Fault in California. An outlier to these 3 boundaries is Hawaii. It is a hotspot in the middle of a plate. So the hotspot will release its magma and it will float up to make an island. As the continent moves due to the convection currents in the mantle, the island will slowly sink under the ocean surface as it leaves and drifts away from the hotspot. The Earth has come a very, very long way to become what it is today. I hope you learned something today. Thank you for watching.